Okay, I'm back, and so here I've added my acceleration to my list of different things that we've been talking about today. And now we want to talk about sign conventions. So this picture should look very familiar to you. In geometry, you had four quadrants that you graphed in. And we said that anything that is to the right was a positive number, things to the left were negative numbers, up was positive, and then down was negative. So we're going to use the same sign convention when we're talking about distances and speeds and accelerations. So that a velocity which is positive means that you are going to the right. If you have a negative velocity, that means that you're going in this direction. If you have a positive acceleration, it means that you're going this way. Negative acceleration is that way. Okay, and then you could also positive velocities and accelerations and negative velocities and accelerations going down. So we're going to use the same sign convention in order to figure out which way that something is going. So I have a very nice little simulation that I want you to look at here. And so this is PHET, P-H-E-T. So go to the internet and find PHET, the moving man. So find that simulation for me. All right, so let's start up the simulation. All right, and you notice that you got this guy here. You can change his position by moving this lever back and forth, or you can also type in whatever position that you want. So you could type it in and then it would automatically go to it. But I'm going to keep it on 0. So that's going to be our starting position. So I'm going to reset this and put it back. Okay, so he's back on 0. Then what does this one do? So what this is going to do is give him either a positive velocity or a negative velocity. So look at the direction that he is going in. So you notice that if he has a positive velocity, then he's going to be going in this direction to the right. And if he has a negative velocity, then that means he's going in that direction. So it's exactly the same as our sign convention that we came up with. All right, so let's first give him a positive velocity but 0 acceleration. So you notice that the acceleration down here is on 0. All right, so let's let him go. All right, and so how would you describe that motion? So that you should have noticed he was traveling at a constant speed. So this is very important. So we had this formula that said your acceleration A was equal to the change in your velocity over time. So in this simulation, the acceleration was 0. All right, now what would happen if I multiply both sides of the equation by t? Well, that would take the t over to this side over here, but 0 times anything is 0. So I could just scratch that off. So now it's saying that 0 is equal to the change in velocity. So that means there's no change in velocity. We could go even further. So we could say that this is v final minus v initial. That was the definition. And then take this and put it on the other side so that I get that my initial velocity is the same as my final velocity. In other words, the velocity is not changing. So anytime that you see an acceleration equal to 0, that means you're going to have a constant speed. Your speed is not going to change. Okay, so let's reset this. And now what we want to do is we're going to give him a speed, but this time we're going to give him a acceleration, a positive acceleration. So I want you to make a prediction. What's it going to look like? So as he starts to walk, what's going to happen? Now he is accelerating. Okay, so now we're going to hit go. Kind of hard to see, but you should have noticed he's speeding up. So his velocity is now changing. So an acceleration changes your speed. So he's going to start to go faster and faster. Now for my final one, so let's reset it. So this time I'm going to give him a positive velocity, but I'm going to give him a negative acceleration. So predict what's going to happen. Positive velocity, negative acceleration. Okay, so did you make your prediction? So let's try it. So what did he do? So you notice that initially he was going in this direction because his speed was in this direction. And then he slows down, comes to a stop, and then starts going in that direction, and he starts speeding up in that direction. So what this tells you is acceleration is the ultimate control knob. So your acceleration will determine, in the long run, your speed. And your speed, in the long run, will determine your position. So even if you were going 1,000,000 miles per hour in this direction, if you had even a small acceleration that way, eventually you would come to a stop, and then you'd start going back the other direction. So acceleration is going to control your speed. Okay, so I hope that you enjoyed that. Now we can go even further with this particular simulation, because you notice it gives you a stopwatch. It tells you the distance that you're traveling. So we could use this in order to verify some of the formulas that we had. That velocity was distance divided by time, and that acceleration was a change in your speed. So we could do word problems and then verify the solutions by using this simulator if we wanted to. And then it also, the next part of this simulation is on graphing, so that we could actually graph the motion of the person, and we could see what is the relationship of a graph to the speed of an object and to the acceleration of an object. We're going to do that later, but not right now. So we're pretty much finished with this, and so we'll put that up, and then our next thing we want to talk about is the how fast equation, and we'll do that in just a moment.